Okay, let's take a look at the midpoint rule. We have the integral from 1 to 5 of 5 cosine 4x over x dx, n is equal to 4. Okay, so from a midpoint rule, we see this goes from A to B. So this is A, and this is B. A wire right now. Okay, now it's out of the way. Okay, so A is 1, B is 5, and so this tells us is approximately we need delta x. Delta x is equal to B minus A over n. So I'm going to have 5 minus 1 over n, which is 4. That's 5 minus 1 is 4. 4 over 4 is 1. Okay, so our answer, we're going to have delta x. So delta x is 1. And then times, and then we got these values right here. And they tell us what these are equal to. Now we're going to have x1 up through xn. X bar sub 1, x bar sub n. So that means we're going to have an x1. We'll have an x2, an x3, and an x4. Okay, and this tells us it's going to be 1/2 and xi minus 1. Now the I refers to what number it is. Well, this one's 1. So if I put 1 here, 1 minus 1 zeros. So we got x sub 0. Now, actually, let me write it out. Okay, so this will be x sub 1 minus 1 plus x sub 1, like that. And the next one, if I put 2 in there, so we got 2 minus 1 plus x, and then we put 2 in there, x2. And you're starting to see the pattern. This would be x sub 3 minus 1 plus x sub 3. And this would be x sub 4 minus 1 plus x sub 4. Now, even more important than that, though, is the picture. I think it's an easier way to think of it. So we got this value, this picture right here. Let's draw it. Now, I don't care what the graph looks like. That doesn't really matter. But here we're starting at 1. And here we're going up to 5. And let me see if I can see this picture here. You can see it up here. Here's x sub 0, x1, x2, x3, x4. So this would be x0 here, x1, so forth. If we split this up, this would be 2, 3, 4, and 5. Because n is 4, then we have 4 subdivisions. Well, you can easily look at this and see what the average is. Well, what's exactly between 1 and 2? Well, that's 1.5. This is 2.5, 3.5, and 4.5. You could use the formula up here. So we'd have 1/2, and this is 1 minus 1, which is 0. X sub 0 happens to match A. So we'd have 1 plus, and then the next one, x sub 1, well, if we add 1 to that, that'd be 2. And 1/2, 1 plus 2 is 3, times 1/2 gives us 1.5. You would come up with the same values as you would with a picture, but I think a picture is easier to see. But again, you have to keep in mind how many subdivisions you have. If you have 8 subdivisions instead of 4, well, then this would, well, you'd have 8 total, but then you'd go from 1 to 1.5 to 2 to 2.5 to 3 to 3.5 on these main lines here. Okay. Let's go back to our formula. So we're going to have f of x bar sub 1, which is 1.5. Plus, and then I'm going to go all the way up and add them together. So I got f of 2.5, f of 3.5, and f of 4.5. Now the 1 is trivial at front, so I don't need to worry about it. If I plug this into the calculator, and this is the part I'm not quite sure about if I need to have in radians. I think I do. And if I go to y equals clear, and I put parentheses on top, so I got 5 cosine 4x, close parentheses, divide by x. And I'll clear out that next line. Now I want to make sure my calculator is set up in the right form mode. So I'll do second window to go in table setup, and I want independent set to ask. So if yours isn't set up to ask, go down to that line, put your flashing cursor on ask, and press enter one time. Now mode, I'm in radians, so that's fine. Now do second graph to go to the table. Now I could type all these in, so I could do 1.5, 2.5, 3.5, 4.5, and that give me those values, whatever they might be added together. You can also do it another way. Now that you put that into your function, you can go into your vars, right arrow to y vars, choose function, and choose y1, do a beginning parentheses, 1.5, close parentheses, plus, go into vars, choose y vars, function, 1 or y1, 2.5. Helps if you actually put the parentheses there. Okay. This is evaluating functions using the calculator. Vars, function, y1, beginning parentheses, 3.5, plus vars, y vars, function, y1, 4.5. And that gives us 2 2.45 1449, and that's how you get that right there. Now that's using the midpoint. Let's take a look at the next rule, 5 cosine 4x. 5 cosine 4x dx 15x n is equal to 4. Okay. Now come over to the trapezoid rule. Now here's our x0 and x4, so it'd be kind of the same setup. You have to know what those represent. A would be this, B would be this, and we need delta x again. So delta x is equal to b minus a over n. So we're going to have 5 minus 1 over 4, which gives us 1 again. So the approximate, we'll have delta x, where's delta x? Right there, 1 over 2. And then we're going to have f of, and okay, so here, the fact that we've already identified this up here helps us. But this is wanting x sub 0, not the average. So x sub 0 is 1. Plus 2 times f of 2 plus 2 times f of 3 plus 2 times f of 4 plus f of 5. Where I got that from is all these have 2's in front of them, except for the first one and the last one, which doesn't have any numbers in front of them. Well, I can put that in my calculator now that I've already entered that. So I can do 1/2, 1 divided by 2, beginning parentheses, f, so do my vars, y vars, function, y1, beginning parentheses 1, plus 2, vars, y vars, function, y1, 2, plus 2, vars, y vars, function, y1, 3, plus 2, beginning parentheses, 2 y vars, y vars, function, y1, and then this is 4, plus y1, uh, 5. And that gives us negative 1.58 4469 192. Assuming I typed everything in right. Let me double check that. Now let me double check the formula. I don't have your email up anymore. Okay, A and B were, okay, that and that. X sub I is equal to A plus I. But if we're splitting it up into four even pieces again, A would be, what would A be? 1. And delta X was, I should double check that. X, okay, let me double check that. We got X sub 0, which is A, which is 1, plus I, which would be 0, times delta X, which was 1. That gives us 1. X1 is 1, which is A, plus I, which is 1, times 1, which is 2. Okay, that works out. And delta x is 1 plus that plus that. Okay, I don't see anything wrong with my logic. This seems weird answer I came up with. Versus here. But I know what cosine does, so that's not too surprising, but I would expect the approximations to be closer.